Welcome. Let's jump right into this explainer and explore the totally fascinating physical realities of our lunar neighbor, the moon. I mean, we've all looked up at the night sky and felt that sense of wonder, right? But today, we're going to look way past the romance and dig right into the hard, gritty science of the lunar surface itself.
So will our footprints on the moon last forever? That is the big question we're tackling today. Now, you might assume that without wind or water, human history stamped into the lunar surface is literally permanent. You always hear people say the Apollo footprints will be there until the end of time. But, well, as we'll see, the cosmos has other plans, and the surface of the moon is actually far more dynamic than it appears from Earth.
Part 1, our nearest celestial neighbor. Let's start with a little context about that magnificent glowing orb in our sky. We're talking an average of 238,855 miles away. And out there, the moon exists in a radically different physical state than our home planet. It is completely devoid of an atmosphere, and it operates on just 1/6 of Earth's gravity. It's basically a rocky, heavily cratered world that's roughly a quarter the size of our planet. Now, here's a detail that actually trips a lot of people up. It does not shine with its own light. The moon simply reflects the light of the sun, kind of like a giant mirror in space. On top of that, it's what we call tidally locked. That means it rotates on its axis at the exact same rate it orbits Earth. The result? We only ever see one side of it. And you know that so-called dark side? It's not actually dark at all. It gets just as much sunlight as the side we see, which is exactly why scientists prefer to call it the far side. Which brings us to Section 2, the mystery of the footprints. So how exactly does this wild environment set the stage for one of humanity's most iconic images? It's kind of crazy to think about now, but before the Apollo landings, there was this very genuine fear that the moon was covered in a deep, quicksand-like sea of dust. Inspired by Arthur C. Clarke's 1961 novel, people were literally worried that a spacecraft and its astronauts would just sink into the surface without a single trace. Well, obviously that didn't happen. Instead, on July 20, 1969, Buzz Aldrin and Neil Armstrong touched down and proved the ground was completely solid. In fact, Buzz Aldrin's famous footprint wasn't just some vanity photo. He deliberately took it to study the fluffy nature of the surface and test the effects of pressure. And in doing so, he stamped an absolute legacy into the ground. But here's the absolute crucial point. That boot print, it isn't pressed into dirt or soil like we know it here on Earth. It's pressed into something called lunar regolith. Basically, regolith is this fragmented, incredibly sharp rock material that blankets the moon's surface, created over eons by meteoric impacts and charged solar particles. To really get a sense of this, let's compare the two. Earth's soil is packed with organic materials, and over time it gets worn totally smooth by wind and water. It's soft. Lunar regolith, on the other hand, is born from extremely violent meteoroid impacts. And because there's absolutely no wind or water up there till you wrote it down, those fractured surfaces stay fresh. It retains these incredibly sharp, jagged edges. All right, let's move to Section 3, the dangers of moon dust. Because it's so jagged, we have to face a really harsh reality about our celestial neighbor. This dust is incredibly hazardous. The Apollo astronauts found out very quickly just how nasty this stuff could be. Try as they might, they just couldn't brush this clinging dust off their suits. It stuck to literally everything, snagging and damaging the spacesuit fabric and threatening to clog the spacecraft's airlock seals. It adhered so easily because of turbocharging, which is basically intense static electricity. Oh, and it notoriously smelled just like spent gunpowder when they got back inside. Today, we also know those tiny toxic nanoparticles could easily lodge deep in an astronaut's lungs, which is a massive health risk. So why exactly is it so clingy and abrasive? Well, it all comes down to its violent creation process. First, tiny, sand grain-sized micrometeorites slam into the lunar surface. That impact shatters and intensely heats the rock. Then, in the vacuum of space, those particles instantly cool into bizarre, jagged shapes. Scientists actually compare them to tiny melted snowflakes. It's these complex, sharp shapes that make them snag on everything, while also reflecting light to make the lunar surface shimmer in these beautiful shades of brown, gold, and silver. Section 4. How the moon erases history. So if we're dealing with a world that has absolutely no wind, no rain, and no volcanic activity, how on Earth, or how on the moon, I should say, does it eventually erase our history? It comes down to two main forces from space. You've got the solar wind, which is this constant stream of charged particles slowly scouring the surface at an atomic level. But that takes a really, really long time. The true eraser?
meteorite bombardment. It's the constant rain of space rocks causing sudden, violent changes that acts like a giant cosmic reset button. Scientists actually call this churning process impact gardening. Essentially, continuous micrometeorite impacts slowly overturn and mix up that top layer of lunar regolith over time. Now, for decades, we assumed this took tens of millions of years, but recent data from NASA's Lunar Reconnaissance Orbiter, the LRO, suggests this impact gardening is happening way, way faster than we originally thought. Look at this updated timeline based on that newer LRO data. Instead of lasting almost forever, those footprints are on a ticking cosmic clock. In about 20,000 years, they'll begin to lose their clear, sharp definition. Jump to 40,000 years, and they'll become virtually indistinguishable from just a small meteor impact. And by 80,000 years, that entire top centimeter of lunar regolith will be completely overturned. The footprint will be 100% erased. Let's look forward now with Section 5, Future Footprints on the Moon. The Apollo footprints belong to history, for sure, but let's pivot to building our future. As NASA gears up for the new Artemis missions, the whole strategy is about learning to live off the land. We simply can't pack everything we need from Earth. It's way too heavy and expensive. We actually have to use that hazardous lunar regolith to our advantage. We're talking about extracting trapped frozen water and gases, growing plants for space agriculture, mixing the dust with cement to create lunar concrete, and even using it to shield habitats from intense solar radiation. And guys, we are already making incredible strides here. In a completely groundbreaking experiment recently, scientists used actual Apollo-era regolith to plant seeds. And get this, they successfully germinated in just 2 days. Now sure, they didn't grow quite as robustly as they would in nutrient-rich Earth soil, but this breakthrough proves that space agriculture using local resources is totally possible. It is a massive game changer for long-term lunar habitation. On top of that, we're figuring out how to build with it. Up on the International Space Station, a project known as the Microgravity Investigation of Cement Solidification, or MICS, is testing exactly how cement hardens in microgravity. By cracking the code on this really complex process, scientists are literally laying the foundation to one day bind lunar regolith with cement to build solid, permanent space habitats. We're talking moon dust concrete. Which brings us to the end of our journey today. We've seen how the moon is so much more than just a dead, unchanging rock. It's this dynamic, totally harsh environment that will definitely erase our first steps eventually, but it's also a landscape packed with the very resources we need for our next giant leap. So, as we prepare to return to our nearest celestial neighbor, we have to ask ourselves, what will humanity's next footprints on the moon, or even Mars, look like? And knowing what we know now about the forces of the cosmos, what kind of legacy will they leave behind? Thanks so much for joining me for this explainer, and keep looking up.